In today's engineering tips, we're going to be talking about FEA, what it is and how it works. Let's get into it. FEA is an acronym. It stands for Finite Element Analysis. It's a numerical method for determining the deformation, strain, and stress associated with bodies or structures subject to forces or enforced displacements. It's a numerical method that involves subdividing geometry into smaller pieces known as elements through a process known as meshing. Once that process is complete, the solver will solve for the displacements, then for strain, and then for stress. So here's how it works. Let's take this simple bar problem as an example. We have a round steel bar attached to a wall with an axial force applied on the end. There are closed-form analytical equations that provide for the deflection at the end of this bar related to the applied force, F, the length of the bar, L, the cross-sectional area of the bar, A, and the modulus elasticity of the material of the bar, in this case steel. However, we can represent the steel bar as a very stiff spring and solve for the deflection at the end of this bar using the classic spring equation F equals KD, where F is the applied force, D is the deformation or deflection at the end of the bar, and K is the stiffness of the bar. The stiffness of this spring, K, is related to the bar's cross-sectional area A, its overall length L, and the material modulus elasticity E. What FEA does is take this process one step further by subdividing the bar into multiple smaller springs. Each one of the springs represents an element in FEA. Each one of the endpoint connections of the springs represents a node in FEA. Essentially, the same basic spring equation, F equal KD, is being solved, except it's being solved for each one of the springs at the same time using a set of simultaneous equations. From there, the deformation or deflection at each one of these nodes is determined, and then from there, the stress and strain within each element can be calculated. In summary, FEA stands for Finite Element Analysis. It's a numerical method for determining the stress, deformation, and strain throughout an arbitrary piece of geometry. That arbitrary geometry can be one-dimensional, two-dimensional, or three-dimensional. The numerical method involves subdividing the geometry into smaller pieces known as elements through a process called meshing. There's much more to the world of FEA, so stay tuned for more videos on how FEA works. Thanks for watching. If there are any questions or anything you would like to see, feel free to contact us or drop a comment below. Don't forget to like, follow, and subscribe to get more engineering tips.